Hello, everyone. Thanks for joining and welcome to Bay Area, San Francisco, Women of MENA in Technology events. Today, we are going to have a fireside chat on robots and drones, how everything is changing. Happy Women's History Month. March is the Women's History Month, and we are very happy that we have our event today. Hopefully by now you had some networking in the networking session. I'm Sarvanos, and along with Hannah and Sahar, we are San Francisco team members from our organization. Our organization is Women of MENA in Technology, and we are a 6-year-old nonprofit organization, and with the mission to empower women in Middle East and North Africa who are in tech or who want to join tech and STEM. For more information, you can go to our website and learn more about us. We need one more team member. We are looking for one more team member, and if you're in tech, working in tech, please send us your resume and LinkedIn profile, and we're gonna contact you. You can read our, you can find our email address on the right side of the screen in the chat box. Check us on our social media on Facebook, Instagram, LinkedIn, Twitter, and Clubhouse. Check our website for our events, upcoming events. We're going to have lots of events, conferences. It's like annual conference where people from all over the globe will join. We're going to have career fair, panels, webinars, office hours, and all sorts of events to empower everyone who work in tech. So please join us. And I want to introduce a corporate ambassador program to you. If you're working in a tech company, you can be our ambassador, corporate ambassador, which is a volunteer position in our organization. So we're going to have an International Women's Day event tomorrow at 10 a.m. Pacific time. There are lots of sponsors from Amazon, Facebook, Netflix, and FewTech. We are going to have our 6-year anniversary on March 29th. You can join that as well. And going back to this event, we're going to have a 45 minutes fireside chat with Dr. Avideh. She's an electrical engineering and computer science professor at UC Berkeley, where she holds a Qualcomm chair. I'd like to ask her to introduce herself and talk about her impressive background more. Before that, I'd like to thank Mariam Bandari, who helped us in preparing the questions I'm asking today. We'll have a 15-minute Q&A at the end of this talk, so please hold your questions, and when the time comes, ask the questions in the chat box, and I'll read them to Avideh, and she's going to respond. With that being said, I'll invite Avideh to the stage, where she can talk more about herself and her impressive background. Hi, Avideh.
Hi, everyone. How are you?
Good, good. I wanted to let you introduce yourself, because you have like a very impressive background, and it's more interactive if you introduce yourself and talk a little about yourself in this field.
Sure. First of all, thank you so much for inviting me today. Glad to be here. I am a professor at UC Berkeley, and I have been at UC Berkeley for about 30 years or so in electrical engineering and computer science. I'm actually in the electrical engineering division. Just a little bit of a background, my professional areas of interest and research are signal processing, image processing, computer vision, and most recently I've become interested in drones and autonomous systems. I joined the faculty at UC Berkeley in 1988. Prior to that, I was a grad student at MIT. And then prior to that, I was an undergraduate student at Caltech. Prior to that, I studied for 2 years in Britain. I was actually on a scholarship from the Iranian government to study, and right about that time is when the revolution happened. And I couldn't go back to Iran, so I just joined my family in the US. Let's see. I guess I would love to hear from all of you, meet all of you, and understand more about what everybody in this meeting is doing, and maybe in the Q&A section, after the Q&A section, we can do a little bit of that. Hold on one second. So do you want me to go downstairs? Okay, sorry, I'm gonna have to relocate because my husband just arrived, so, and my charger for my laptop is also downstairs, so apologies.
Sure, no worries. We're gonna have a networking session with Avideh after this event. It starts from 1:30 to 2:30 p.m. So everyone, please join after the talk, and you can have one-on-one with Avideh and ask whatever question you have. So with that being said, I'd like to start the questions. First, I want to go over some questions about drones. The first question is, what are the applications and challenges about drones?
Yeah, so I'm really excited about the possibilities that drones offer. It's an exciting technology. It's a new technology. It allows us to do things in a much more efficient way that perhaps before was not possible. I would start by one or two projects that I've been involved with. One has to do with search and rescue missions. When there's a natural disaster going on, or disaster of any kind, and you want to identify the people who are still alive, either daytime or nighttime, drone technology is very useful. Applications in agriculture, ag tech, they call it, applications for examining utility lines and power lines, applications for building energy efficiency, applications for painting buildings. I have a lot of work going on, sponsored by Department of Energy, in the area of building envelope energy efficiency. So for a lot of those, drone get used. So it's a lot of, there's a lot of nice applications, and there's also a lot of nice technical problems. Most recently, people are talking about UAM, urban air mobility, which really takes drones. It's not really drones anymore, but it's really for transporting people from one location to the other, but in a one-man, if you will, helicopter or airplane, where that system, you can't really call it a drone anymore, but it's being autonomously driven. So what I just talked about doesn't exist. It's really, at this point, science fiction, but a lot of interesting technical challenges for electrical engineers, mechanical engineers, battery people, all kinds of technical challenges that have to be solved to make that a reality. So I really think that if in 50 years or so, if you were to visit Earth from somewhere else, you'd see a lot of different transportation modes than what we have now. We won't be stuck to the ground forever. Just a little joke, when I was a kid in Iran, like in 3rd or 4th grade, my dad used to always drive me to school, and there was so much traffic jam. And I would tell, Dad, why can't you have your car just jump over all these cars over on the other side so I can be at school faster? I said, well, I leave that for you to invent when you grow up. And there's not every time I talk to my dad, I still remind him of his comments, and I leave that for you to invent. It is now time to think about it and invent it.
That's very exciting. So you almost answered this question also, where I wanted to ask, what do you think about future of drones? Do you want to add anything to it?
I think the future is really bright. The issues that we have to, and they're going to get used more and more in more applications. One of the biggest obstacles that I see is coming up with rules and regulations that deals with the multiplicities and the numbers of drones in the air. So FAA in this country, FAA, Federal Aviation Agency, has to come up with precise rules, and believe me, the rules are really restrictive. You can't be near airports. The drone has to be within line of sight to where you are. You have to have a special license if you don't want to do that. And you can only fly it so high. The line of sight restriction is, to me, by far the most limiting one, because and I found out about it fairly recently. I was writing a proposal where I was going to use a drone to survey a 20-mile by 20-mile, 400 square mile area. And we had done a small building in Alameda that took 30 minutes with one flight, but then to do 20 square, 400 square kilometers, you need to, this business of drone being in your site is just not going to scale, and you need you need to be able to have it fly out of sight and be able to do the scanning that you need and the data collection that you need. So yeah, a lot to think about by various governments as to how they're going to manage the airspace, the control, the air controllers, to prevent various air vehicles not to collide with each other. So maybe we have one layer near the ground, one layer above it, and then in other words, at different altitudes, you have different kinds of flight services that are going to be offered. Remains to be seen how that's all going to evolve.
That's very exciting. So I have an ethical question. People think if they work in this area, their help goes to the military or it removes people's job. This is a concern, especially with drones that are heavily used in the military. What's your thought about these statements?
So, for every application, there's for every technology, there's peaceful and not so peaceful applications. So I think as an electrical engineer, I'm always interested in extending the envelope of what's possible, and hope and pray that whatever I invent is used for peaceful, positive purposes. Through all the examples the biggest, most well-known example of that is nuclear science, right? The same nuclear technology can be used to generate energy and provide electricity for our homes, but it can also be used for destructive purposes. Yeah, I tend not to. So my thinking is that if I'm working on extending humans' knowledge and extending frontiers of technology, then that's already a very positive thing. But how it gets used and who uses it is a little bit outside my control. And hope and pray that what I come up with is used for useful and peaceful kind of purposes. And in terms of improving efficiencies and productivity on all the applications I just mentioned, agriculture, construction, traffic management, all of those, utility lines, inspection, all of those. There are many peaceful and applications of it that. So I don't think it's only for military purposes, and if military wants to use it, then we can't really stop them.
Right. Another question about vision in drones. Can you talk about challenges of computer vision that are specific to drones rather than robotics?
Right, right. So one of the biggest challenges of drones is obstacle avoidance. I mean, if your drone bumps into things, it just crashes and you have to start from scratch. And believe me, it's really sad when your drone does die, does crash. But in terms of obstacle avoidance, I think one of the most interesting problems there is um, detecting thin objects, like thin, um, small tree branches or wire lines. So generally speaking, drones have either LiDAR or depth sensing sensors in front of them to detect obstacles. But these sensors don't have a lot of resolution. And so if you have a thin object, they could just miss it. On the other hand, if you have RGB cameras, visible light cameras, you could have a lot more pixels and a lot more resolution. And perhaps you can apply some of the photogrammetry type techniques in order to detect those objects. Now, having said that, one of the main problems with obstacle avoidance using just RGB cameras is that because the optical axis of the camera is parallel to the direction of motion, you get very little what's called motion parallax. So traditional computer vision techniques don't work very well in depth estimation using just RGB in that scenario when you're moving just along the optical axis. So one of the areas that my students, for example, right now are looking into is coming up with ways of getting around that problem. So instead of using what's called optical flow, you have to use something called optical expansion. So the idea is that as you're moving along the in the forward direction, and you have a camera that by definition and by necessity is looking forward, the objects that are far away become bigger and bigger. So they occupy a bigger and bigger field of view in your pictures. And so you can use that clue as a way of knowing how far objects are and avoiding those kinds of obstacles. So that's an area, very interesting area of research. Another interesting problem with drones is that because they're flying high up and looking down, you have really high resolution, ultra high resolution images on the ground. But for recognition applications, the objects of interest are really small. So if you're doing autonomous driving and you have a camera on your car, there's a car in front of you appears as 200, 400, 600 pixels. So it's not that difficult to miss it. But when you're flying high up and you're taking a big high resolution image, a car could be like 5 pixels. And so things like object detection and object recognition becomes a lot harder. And in general, finding small objects in big images is another really challenging computer vision problem that I'm interested in and kind of working on. Another place, non-drone area that this problem comes up is another project I'm having in collaboration with UCSF, where we're looking at what's called whole slide imaging of melanoma pathology samples. And so there you have images that are 40,000 by 40,000 pixels, very large resolution, and you're trying to find cancerous pieces of it that are small patches of 10 or 20 pixels. So it has nothing to do with drone, but the same kind of techniques of finding a small object in a big high resolution image that comes up in drones also comes up in this other research. So this is the same kind of tools could potentially be applied to both.
Mm-hmm. Interesting. Another question is, how did you actually enter into this area? Many women don't go into this field. What was your path to this journey?
So, when I was a grad student at MIT, my thesis was in multidimensional signal processing, which is, pretty hefty term. But in simple terms, it was the beginnings of image processing. So when I joined the faculty at Berkeley, initially I was just looking at image processing and image reconstruction. That got me interested in applying image reconstruction techniques to semiconductor industry, particularly for the optical lithography step, and that resulted in my first startup, Mentor, which was acquired by Mentor Graphics about 25 years ago or so. Then gradually I became more and more interested in image and video communication. And then gradually I became more and more interested, and communication meaning how, essentially this 25 years ago, this idea of sending video over packet switch networks was very new and very difficult to deal with. Now it's a given. After that, I became more and more interested in 3D problems. So if you have an object, what if you make a camera go around it? Can you create a realistic version of that object so in a virtual space so you can interact with it? And that's the beginnings of virtual reality. And then after that, I became interested in the reverse problem, where you don't have an object that you want to make a 3D model, but you want to make a 3D model of the space. So between 2000 and 2007, I had a really nice project where we put a bunch of sensors on top of a truck, like laser scanners and cameras and IMUs and gyroscopes. And we started driving around city of Berkeley, making 3D models of city of Berkeley. Eventually, that caught the attention of the Department of Defense and DARPA. They launched a project to further improve that process. And then 2 years into that project, Google became interested in that technology and acquired our little startup. And that was the beginning of what you now see today in Google Earth. So that's 3D modeling of cities. And then from there, I became more interested in 3D modeling of indoor environments because then there's no GPS, and the problem is much harder from a technical point of view. So what I'm trying to say is that, research is your research interests and what you work on, at least at the university, evolves over time, and you kind of have to be you're to some extent you're opportunistic as to what things comes your way, but to some other extent you can kind of like adapt and work on problems that interest you, as long as you can secure funding for it and hire enough grad students and researchers to come into your team to work on them. But how did I get into drones? So at the end of all the indoor mapping stuff, that was my last, I guess, startup, and that was acquired by another company in 2019. I came back to the university, and I started a collaboration with LBL. But with the indoor mapping stuff, we were very interested in doing the indoor mapping with the idea of improving building energy efficiency. So the way I got into the drone stuff was that around the same time I started a project with LBL where we used the drones to come up with the thermal maps of buildings in order to examine the thermal efficiencies and find out the thermal anomalies, leaky windows, et cetera, et cetera. So that really kind of got me started looking into it, and just, yeah. And so that's how I got into the drone stuff. Right now, I'm also looking at other projects where we're making virtual models, 3D models of cities, and we put it inside augmented reality glasses so that you can kind of like see annotations and find out more about your surroundings as you're driving or as you're walking, etc. So they're all, I guess, 3D modeling and 3D reasoning is one of the areas that I've been interested in for the last almost 20 years or so. So drones come in because they allow you from the air be able to reconstruct and come up with 3D models of cities a lot nicer than what my student and I did back in 2000, where we had a truck with sensors and drove around kind of thing. By the way, in 2000, we also flew to get aerial pictures, but it was with an airplane equipped with a LiDAR, and it was expensive, and helicopters, it was expensive. The thing that excites me about the drone is it's so cheap and it's so available. When we started the project with LBL was going to purchase a $20,000 drone, but it took them so long to process that. Meanwhile, the grad student I was working with, Mark, he said, "Hey, professor, I just got this, $800 drone as a Christmas gift. Can we use that for our project?" I said, "Sure." And for the first year, we just used that $900 drone to capture all of our data until LBL's drone eventually came through, and there's so much red tape and everything. But anyway, the point is, the price point has come so low that it makes it a no-brainer to be using it for a lot of applications that were previously not possible to use.
Mm-hmm. Okay, with that being said, how should you, like young researchers, choose their area? What should be the deciding factor? What's the next hot area? And how should they learn where this field is going?
Yeah, I think that's a good question, and it's a hard question. What exact area do you want to focus on? I think some of it you have to be kind of like opportunistic to see what's available, but some of it also should be your own passion, and what gets you excited. I find that I usually do best when I work on problems that I'm super excited about, rather than problems that other people just handed down to me to work on. So that's, I think, if you like what you do, even if you're a plumber, you do really well. One way to kind of one advice I have to young researchers is to read a lot, by a lot of the technical journals, conferences, papers that come out. Technology moves really fast. Fields evolve incredibly fast. So the only way to be aware of what's hot and what's not hot is just to be a voracious reader and allocate n hours a week of just catching up with what's going on. If you're electrical engineers, it's IEEE transactions on just about everything. If you're a computer scientist, it's ACM publications and conferences, etc. So kind of, if you're into computer vision, when CVPR puts the papers online, go read them all, and that way you're always on top of what's going on. The other thing is attend as many talks, technical talks that people give, because then you're always in the know of what are some of the latest trends and what are the hot things that people are thinking about or working on.
Mm-hmm. To add that, can you talk about the importance of having the community and building one that can thrive and help people, people in this area to grow?
Yeah, sure. So you can have technical communities you're members of, either at school or at work. You can have network communities like this one where you network with other like-minded people. But if you are already working, your technical community basically becomes pre-COVID days would be the conferences that you would go year after year. Like for my profession, I've been going to this international conference on image processing and also computer vision and pattern recognition conference for the last 20 or 30 years. So year after year, you kind of like bump into the same people. You keep track of what they're doing. They keep track of what you're doing. So that's a lot of science and technology is done by personal one-on-one kind of relationships of people with each other. Obviously, reading and being up to speed is good, but interacting with others and collaborating. If you're starting a new project, it's always nice to have multiple perspective and multiple teammates if you can afford it, to be able to leverage your ideas off of each other, bounce ideas off of each other, and make better progress that way.
Yeah, that's a good advice. So going to robotics now, I'll ask you some questions regarding that. So what are the areas in robotics you think we may call solved areas, and which areas do you think still need years of experience?
So I think within robotics, some of the most stunning successes have been in the area of, for example, simultaneous localization and mapping. This idea of I have a robot, I equip it with a bunch of sensors. Either I control it with the remote control or let it explore an area, navigate, and create maps of buildings. That's a huge success story within the robotics kind of community. What's not what's not solved, and what's really still very hard, is to get the robots to do some of the tasks that we do. When I want to, let's say, pick up this mouse that's sitting on my desk, right? I don't have to do a whole lot of calculations in my brain where which finger, which hand, which joint I have to move. That really simple task that maybe a 2-year-old knows how to do, even a 1-year-old knows how to do. I mean, if you have a baby, you give them a bottle at 4 months old, they grab it and put it in their mouth and they start drinking it. They learn that at 4 months old. You can't really teach. It's very hard to teach something like that to robots. Things like imitation learning, etc. And it could be that for years people would be solving, hard mathematical optimization problems as to path planning to figure out how an arm should move to pick up an object. And now kind of the thinking is different, is that, okay, maybe we want to learn a whole lot of set of basic skills, and then on top of that, build this more complicated skill of picking an object up. I think manipulation, grasping, and simple things that we as humans learn at a very young age, those are still pretty much missing in robotics. I mean, the solutions that exist work under very limited, constrained environments. Like you have a robot arm, there's a belt underneath, there's objects passing by you, you do a repetitive task one after the other after you program the robot. But even programming the robot many times is tedious and not very easy to do. So I guess in short, what we haven't achieved is being able to having to come up with robots that can do things as painlessly and as easily as humans do, even a 2-year-old baby or person does. That's the big challenge. And there's progress being made. There's things like reinforcement learning, there's things like limitation learning, deep networks have come to the rescue, but I would say that deep learning stuff has had a lot bigger impact in computer vision so far. It really moved the object recognition problem from being an unsolved problem, maybe 2010, to a nearly completely solved problem, and in the simplest form, not that nobody had even thought that would be possible. But the same advancement in robotics hasn't really happened. So there's a lot more to do in that topic in the robotics area.
Mm-hmm. Okay. So next question is, what is vision pre-ML was already very advanced. However, it didn't really contribute much in the field of robotics until recently, when machine learning and vision started. Why do you think that is?
Yeah, I think I talked about that a little bit just now. I think computer vision, in a way, it solves simpler set of problems. I mean, at its simplest level, the object detection problem is, okay, I have these many pictures, you tell me which one of these n categories of object is shown in this picture. So it's a more contrived set of problems, it's simpler. Robotics is much broader. I mean, you've got the hardware aspects, and then you have the software aspects. There's a famous video that Peter Abil at Berkeley made, where he showed that there was a human controlling a physical robot, the fingers of a physical robot, and it did all kinds of things, like empty the dishwasher, broom the floor, make coffee, etc. Then at the end of the video, he just turns the camera on and says, well, the hardware was there and this person just controlled it. And this proves that for robotics, all you need is software. There's no shortage of hardware. There's no missing important part in the hardware part. And all you need is to have software that allows you to do things. And so the problem with that software is that software has to interact with the physical world. and it has to work under all conditions, all environments, all kinds of cups, all kinds of coffee makers, all kinds of, you know, dishwashers, if you will. So generalizing that, so people use machine learning in robotics a lot. The real challenge is that you solve the problem of grasping this pen from this particular table under this particular lighting condition really well, but generalizing it to a different object at a different desk at a different room and a different lighting condition is very hard. It's the generalization problem that puts a lot of challenges, that creates a lot of challenges in front of us. And whether or not, you know, deep learning can do that, hopefully it will. But one of the trends I see that is that you need a lot of computation power to solve some of these deep learning / robotics problems, to solve the software algorithmic aspect of it. And unfortunately, that makes it such that only few select industrial labs with mega computing capabilities or have the possibility to run those complicated algorithms. I just tell you a little story. You know, I have something like 20 or 30 high-end workstation in my lab, and one of my students went for a summer job at an autonomous driving company 2 years ago. And when he came back, I said, "So how was it? What did you work on?" He said, "Well, I can't tell you what I worked on, but when I ran my algorithms, it was running on 300 machines, not the 10 or 20 that you have in your lab." It was really a humbling moment, because I used to think my lab is one of the best, and we had so much good compute capability. But then when they go to industry for a summer job, they have compute capability that's like 20 or 30 times better than what we have at the university. So to me, that creates an uneven playing ground for coming up with good ideas. And so many times when we go to conferences nowadays, you find that the big 5 industrial companies that have mega computing power, like Amazon, Facebook, Google, Apple, etc., they end up, that translates into technical results that exceeds what the small players like universities, for example, or small businesses or small research outfits can produce. So that's a little bit unfortunate, but that's kind of the way it is right now.
Mm-hmm. So following this question, this talk that you had, I have another question. You almost answered it, but let's go more deep into it. Robotics has been around from the 70s and even the 60s, and yet the field has not advanced as much as the rest of the computer science. For example, compared to algorithms or like optimization, robotics has not moved as fast. What are the challenges which make the research in robotics harder? And do you think that now we have overcome those challenges and the field is on another bloom?
I think the field is moving faster than it was maybe 10 years ago, but there's still, it's still a good amount of challenges. Again, in terms of programmability, of teaching a task to a robot and being able to program it in a simple way, not spend a lot of examples, not spend a lot of time, etc. That remains to be the holy grail of the whole field, and that's still an unsolved problem. Being able to come up with teaching robots to do something that doesn't need a million examples and that's fast and affordable. So again, the hardware is there. There's a lot of companies that make the arms and the robots and the platforms that are needed, but you know, teaching the robot to do what you want to do quickly is and flexibly and in a generalizable way is still very hard.
Mm-hmm. So I have a closing question, and then we'll go to Q&A. I'm sure you get asked this question many times. Do you think we'll have another AI winter soon?
I don't think so. I think that for the longest time within AI, we were kind of debating whether we want to do rule-based stuff versus example-based stuff. So the deep learning wave that has hit us in the last 10 years has enabled quite a bit of progress in some fields more than others. Natural language processing, image processing, computer vision definitely have made really good progress the last 10 years or so. I don't think we're going to go through any kind of an AI winter, but I think we do have to be careful about not over-promising. For example, an example of a company that bet very big on AI was IBM and the use of AI for health applications. And after 10 years of putting a lot of money into it, they discovered that it's a tough field, and the fragmentation of data records, privacy issues, those all come into play in applying some of the techniques that one has, some of the powerful AI techniques to these fields. So, that's one thing we have to be careful, is not to overpromise and underdeliver. But the other thing that's important is a lot of the deep learning stuff, machinery that we develop, under best circumstances, they need a lot of examples and data for them to work and to flourish. And so we shouldn't lose sight of that. There are many examples for which there's not enough data to be able to do some of the things that AI is good for, deep learning is good for. So I'd say I'm cautiously optimistic that we're not going to hit another winter. But we as technical people should also be cognizant of the fact that if we blow it out of proportion and promise too much and deliver too little, at the end we lose credibility, not just one of us, but all of us collectively. So that needs to be kept in perspective. One other side comment is that this deep neural network stuff was around already 30, 40 years ago. It didn't go anywhere at that time because the compute power was not there. It's kind of interesting. In signal processing, which is the field that I'm most familiar with, Gauss invented fast Fourier transform about 200-300 years ago by observing the periodic motion of the planets, right? It took 200-300 years after that before people at IBM, Cooley and Tukey in 1963, they rediscovered this fast Fourier transform algorithm to do speech processing, and that's how the field of digital signal processing got launched. So in technologies, there's always this play between algorithms and machines that make the algorithms possible. I would say the same thing that happened in DSP is happening with deep learning. The neural networks were in discussion and were hot in 1988, early 1990s. But why is it that suddenly they didn't go anywhere? For the longest time, they didn't go anywhere. But how is it that they were revived again? With this guy, Alex Krizhevsky, in 2012, ended up making a much bigger neural network. And the reason you could do the much bigger neural network is because there were much better computers in 2012 than there were in 1990. So one more time, the interplay between computing power and algorithms is what pushed the field forward. And also the availability of data. The amount of data we were training things with back in the 90s was very little. And so the availability of the data and also availability of high power computing is what propelled the field forward. So for now, as I said earlier, we just have to make sure we don't overpromise and underdeliver, because if we apply it to problems for which there's lack of data, for whatever reason, privacy reasons, And if we can't come up with performance guarantees or bounds of performance, which is very hard to do because a lot of the deep learning stuff are not explainable or very hard to explain. It's kind of like a black box. Data goes in, data comes out. So with all these caveats, we have to make sure that we shouldn't be thinking about this deep learning stuff as a panacea, if you will, because it doesn't solve all the problems in the universe, but it's a step forward. And really, it's our jobs as scientists and engineers to make sure that we understand the answers that these black boxes produce and hopefully understand more about why is it that they perform the way they do, and apply it to the right problems. The classical methods of non-deep learning, signal processing, stuff like that, those still have their places. And many times, at the end of the day, you might want to end up with a deep learning AI system that has some physical kind of characteristics coming from classical analysis and derivations, and then together with the data part that deep learning brings into it. So some sort of a hybrid solutions will probably become very important in the future.
Okay. Great. Thank you for the great discussion, and it was very insightful discussion, basically. So I want to ask like our audience to have their questions written in the chat box so that we can start the Q&A. So I see that some people have started their questions. So let's start with Martina's question. She's saying that you talked about one application of drones for building energy efficiency studies. Are there other areas you can think of or you know of?
Yeah, for example, in agriculture, people use drones in order to figure out the growth stage of what the plant had. The other really big one is utilities inspection. So PG&E has to inspect all this. The people have to climb up these really tall poles to get to the top to see how the wires are doing, how the transformers are doing, transmission towers, etc. So that has a lot of safety issues associated with it. So if you send a drone and you can take pictures of it, you can do essentially inspection of infrastructure. This is not only just utility poles, but like bridges, buildings. Is this bridge developing a crack? So high resolution imagery off drones could be very useful for those kind of things. Agriculture and also for construction, monitoring progress in construction, planning it, etc. That's a big area as well. Yeah.
Okay. So another. I think
We're back again, I think.
We lost the connection for some reason.
Can you hear me?
I don't see Avideh's video. So if you lost your connection, please share your audio video again so that we can see you. Sorry about the technical issue. I'll just ping Dr. Avideh.
Oh. I can hear you. Can you hear me?
I think your microphone is on. Can you like talk to see if we can hear you?
Yeah, I think the audience thinks that the audience hears both of us.
Oh, okay. I don't see or hear you, but I'll keep asking the questions. So the follow-up question to the applications were how the on-air duration of drones is limiting to these applications you talked about, if at all, and how would you tackle such challenges?
Yeah, that's a really good question, and it's a really a big problem. So yeah, the drones can do something of the order of commercial drones anywhere between 25 and 55 minutes. So that's really a battery limitation. So you can approach that problem from both ends. You know, if you increase the battery performance with better storage capability, etc., then you can increase the flight durations. The other thing is you can perhaps come up with more efficient propulsion technologies or more lightweight planes that can still do as much as the heavy duty planes, not planes, I mean drones. So yeah, it's an interesting area, and it also relates to the urban air mobility, like single human kind of like plane that we talked about earlier. It also relates to electric cars, if you will. So efficient battery technologies is always very important. So I'm looking at.
Next question is, do you work on ground drones also?
Not really. Drones, when I think of drones, I only think about drones that are flying. I'm actually looking at the other questions. This is with the rise of drone companies like Skydio, Matternet, and Zipline, do you have any opinion of who is leading the industry? That's a really good question. Uh, I like Skydio quite a bit. I actually had a demonstration of their system less than 2 weeks ago or so. Um, I don't know too much about Matternet and Zipline, so I don't want to be advocating for Skydio or any of these companies. One of the big issues that has come up in this drone field is that, as you all know, the biggest drone company in the world is DJI, which is a Chinese company. And there's reason to believe that the images that are captured during a drone flight might not might be available to the parent company that sells the drones, and so there's a lot of concern about both privacy, but also especially for U.S. government projects, and also for confidentiality, that not to use DJI drones for applications that are military sensitive or defense applications, etc. Um, having said that, I think from a price point of view, the DJI drones um, are fantastic. As I said, you know, it's a Christmas gift that of my student from his grandfather. It enabled us to do a whole 2 years worth of research before we had to go buy, you know, expensive drones. So from a price point of view, DJI is definitely the leader, but I can see why there are situations where other drone companies with better obstacle avoidance and better AI and better programmability capabilities can also make inroads into this field.
Okay, so Unfortunately, I don't hear you, but looks like everyone else can hear you. And so I want to thank you so much for your time, Avideh, to participate in this event. It was like very insightful talk, and we learned a lot from you. So with that said, I want to close. If anyone has any question, please ask. Otherwise, I want to direct everyone to the next session, which is networking with Dr. Avideh, and we'll see you there. Meanwhile, please, if you have any question, get it ready and ask her in her networking event. Thank you so much, Avideh.
Thank you.